All right, welcome to this explainer. Today we're getting right into it, talking peer-to-peer with the cloud architects, DevOps engineers, and SREs out there. We all know managing cloud-native platforms can be, well, total chaos. But today, we're breaking down exactly why GitOps has emerged as the definitive target operating model to basically cure that chaos.
Because, this is the ultimate goal, right? Operational consistency at enterprise scale. It's our holy grail and, honestly, our biggest nemesis. When you're managing 10 servers, sure, manual tweaks are risky, but at thousands of nodes, they're absolutely catastrophic. We need absolute predictability. No more Friday night deployment panics, no more undocumented hotfixes bringing down production on a random Tuesday. We've all been there, and it's time to move past it.
So, here's our agenda for today's architecture review. 1. Cloud scale operational challenges. 2. Defining the GitOps framework. 3. Core principles of GitOps. 4. The complete GitOps workflow. 5. Platform engineering integration. And 6. The Git-driven future. Let's dive in.
Starting with Section 1, Cloud-Scale Operational Challenges.
Look, as platforms grow, these challenges aren't just minor inconveniences anymore. They are strict SLA requirements. Enterprises desperately need reliable deployments, staging environments that actually mirror production, for once, and pristine auditability. But above all else, we have got to eliminate configuration drift. You know what I'm talking about? That silent killer where your live state just slowly mutates away from what's documented, all because of unchecked manual interventions.
Okay, moving on to Section 2, Defining the GitOps framework.
Here's the architectural definition we really need to lock in today. GitOps is an operational framework that uses Git as the single source of truth for infrastructure and application configuration. Git isn't just for your app code anymore. In this model, Git is literally the ultimate control plane. The rule is simple. If it runs in your cluster, it must live in Git.
Just look at the contrast between these two paradigms. The old approach is what we lovingly, or maybe not so lovingly, call ClickOps. Engineers logging into servers via SSH or manually running kubectl commands against live environments. That is a massive anti-pattern now. Think about it. If an engineer manually patches a production cluster during a 2 a.m. outage but forgets to commit the YAML, the very next deployment just wipes out their fix. The new paradigm shifts the engineering culture entirely. You update YAML or Terraform in a repo, and automation handles the rest. We're talking about moving from manual chaos to highly governed automation.
Section 3, Core Principles of GitOps. So, GitOps rests on these 4 absolute pillars. First up, declarative configuration. Your desired state has to be defined as code. You aren't scripting the steps to get there, you're just declaring the end result. Second, version control. Every single change goes through Git, which gives you this beautiful, immutable, cryptographically verifiable ledger. Third is automated reconciliation. Your platform must continuously run an infinite loop, observe, diff, act, to constantly compare the live state to Git. And finally, number 4, pull-based deployments. Now, this is an absolutely crucial distinction from legacy methods. Instead of a fragile CI pipeline aggressively pushing changes into a cluster, which, let's face it, opens up massive firewall and security holes, you have software agents living securely inside the cluster, pulling approved configurations inward. All right, Section 4, the complete GitOps workflow.
Let's process this end-to-end architecture. Just take a look at how the flow moves flawlessly from left to right. After that initial code review, there isn't a single human bottleneck. The pull request acts as your gatekeeper, policy validation handles security seamlessly, the continuous delivery agent syncs the state, and boom, your Kubernetes cluster matches your repository perfectly. Automation entirely replaces those clunky manual delivery pipelines.
Let's zoom in and isolate just the first half of that pipeline for a second. A developer makes a change to an infrastructure config and pushes it. To get that change merged, they open a pull request. Now, in the enterprise world, this PR essentially replaces your legacy change advisory board, right? Infrastructure changes are now subject to the exact same peer review rigor, linting, and approval processes as your standard application code. You are finally bringing true software engineering best practices over to your infrastructure.
Moving into the second half of the workflow, this is where we see the real power of the automation. Once merged, policy validation kicks in. Think of tools like OPA or Kyverno, enforcing security natively as admission controllers. Like, if an ingress is missing a TLS certificate, the deployment is blocked right there, no exceptions. But once it passes, the GitOps agent takes over. It continuously pulls Git and strictly enforces that desired state right onto your Kubernetes cluster.
And to actually execute this continuous reconciliation loop, the industry relies on some real heavyweight controllers, We're mainly talking about Argo CD, Flux CD, and Jenkins X. These tools live inside your cluster natively as custom resource definitions, or CRDs. They sit there constantly asking Git, hey, has anything changed? And applying diffs in real time. Plus, they provide massive visibility into the health of your deployments directly from within the Kubernetes control plane. It's a total game changer.
Section 5. Platform Engineering Integration. GitOps is honestly the engine of modern platform engineering. Platform teams rely on it to securely deploy core infrastructure and enforce org-wide policies across vast fleets of Kubernetes environments. But maybe most importantly, it powers internal developer portals. This means developers can self-serve a new database, provision an S3 bucket, or stand up a whole microservice environment just by opening a pull request. It completely empowers developer velocity, and it does it without compromising an ounce of compliance.
And the operational payoff here, it is massive. Real-world enterprise implementations are seeing their mean time to recovery drop from hours to literal seconds. Why? Because your entire state is versioned. Rolling back a catastrophic failure is quite literally just a simple git revert. And think about disaster recovery. In a multi-region outage, DR isn't some dusty 50-page runbook anymore. You provision bare compute, install your GitOps agent, point it at your repo, and watch as the cluster completely reconstructs its own state from scratch. Plus, any configuration drift gets corrected automatically along the way.
Finally, Section 6, the Git-driven future.
Look, if you remember only one thing from this entire architecture review, please make it this golden rule. If it's not in Git, it doesn't exist. Period. This is a non-negotiable architectural standard. Any manual change made directly to a cluster is an anomaly, and your GitOps agent should, and absolutely will, immediately overwrite it. Git is your absolute, unwavering source of truth.
So here's my practical recommendation for every technology leader and architect tuning in right now. You need to transform your perspective. Elevate Git from being just a mere source code repository into the central operational control plane for your entire cloud environment. Adopting GitOps is, quite frankly, the only proven way to achieve consistency, security, visibility, and true operational excellence at enterprise scale.
I'll leave you with this provocative thought to take back to your engineering teams today. Take a really close look at how you manage infrastructure right now. Is your cloud operations future fully declarative, completely automated, and unapologetically Git-driven? Because if it isn't, well, you're already falling behind. Thanks for joining me on this explainer, and I'll catch you on the next deep dive.